Hello everyone. Well, we're going to talk about logistic regression this week. This is week 8. We'll have week 9, we'll talk about clustering, and week 10, there will be no new topics introduced. We'll just go through the final project. Logistic regression. I put a subtitle on this that says that this gets pretty mathy, and it does. If you want to really dig into it, it gets pretty mathy. I've tried to put together a couple slides and a script that will allow you to sort of get through the concept of logistic regression and actually practice a little bit of using it without it getting too mathy, but it can get pretty hairy. If you've watched the Brandon Foltz videos, he doesn't get too mathy until he gets to the third one. And the third one, he talks about the logit and exponential notation and probability and odds and all that great stuff. Go to if you want. It will make this a little bit more clear. But I'm not going to require you to do that. Okay, let's go back a little bit. Remember, in linear regression, we built a predictive model based on a single variable. So we looked at all variables, or we looked at a variable that we thought was going to be a good match, and we based a predictive model that said, all right, when this variable goes up, the dependent variable will go up, and when this variable goes down, the dependent variable will go down. And it was a pretty linear relationship, but it was based on a single variable, and so it wasn't very accurate. Then we moved on to multiple linear regression, where we actually looked at multiple variables. And what that would allow us to do is build a much more accurate model because it was built on the behavior of multiple correlated but not suffering from collinearity variables. We were able to build a predictive model that was based on several variables, and then we could predict the value of the dependent variable. In KNN classifier, which we did last week, what we really did is we just determined which class a record belonged to based on its proximity to some number of records, some number being what we set for K. So that was really kind of moving along from building predictive models to looking at a single classifier model. I talked a little bit about naive Bayes as well, but we really didn't dig into it too much. With logistic regression, we're going to kind of cover both because we're going back to regression and we're going to use regression. But we're going to use regression in a different way. But we use regression not necessarily to calculate a value. We're going to use regression to predict a class. So let's go through some of that. All right. First off, let's talk about the two different types of variables that impact us in regression. There's continuous and categorical. In the linear regression and multiple variable linear regression models, we use continuous variables, meaning that we input a bunch of values, a bunch of different values of coefficients and an intercept, and we let the model sort of create for us a value that could range from pretty much any value, negative values, 0, all the way to positive values. And those are just continuous variables. There's just basically values on a scale. It could be any one of those numbers on a scale. But a categorical variable is one that basically has a very limited number of categories. It can be yes, no. It can be approved or not approved. It can be, for example, for education, it could be graduate, undergraduate, or advanced. It could be male, female. These are categorical variables. And that's where we really differ with logistic regression in the sense that with logistic regression, we are inputting variables just like we did with linear regression. But what we're looking for to come out of logistic regression is going to be what class that particular record belongs to. Based on the values that came in, what class can we predict for that particular variable? Here are some examples of where we would use logistic regression. One example is in the medical field, to develop a model to determine the likelihood of a patient's response to medical treatments or procedures. So the input variables we would have could be age, weight, blood pressure, and cholesterol levels. Those are all continuous variables. And what we're going to do is we're going to use all four of those continuous variables in a model to determine whether or not the patient is likely to respond or not respond. Again, we're getting back to the categorical variable. This is all from past data sets. So if we look at past data sets with thousands of records where we have variables like age, weight, blood pressure, and cholesterol levels, and we're looking over those thousands of records because we know whether or not the patient has responded, we can build that model. Then we can take that model and we can apply it to future data sets and help us predict whether or not a patient is likely to respond to a particular treatment. In finance, we might use a loan applicant's credit history and the details on the loan to determine the probability that an applicant will default on the loan. So based on those predictions, the loan can either be approved or denied, or we can modify the terms. In marketing, we can determine a wireless customer's probability of switching carriers, known as churning, based on age, number of family members on the plan, months remaining on the existing contract, and social network contacts. We could use that information to target customers who are more likely to churn. And then engineering, based on a number of characteristics, we could determine the probability of a mechanical part experiencing a malfunction or failure. And then we can estimate a schedule, or use that estimate to actually schedule maintenance. Here's a little bit more of the mathy part. So what we're really looking at here is really looking at generating values, and these are likelihood values. If you remember from probability, probability is run from 0 to 1. And so something that is 1 is very, very, well, it's always probable. Something that is 0, it's never going to happen. But in this particular case, the logistic regression is going to return a value that is anywhere from 0 to 1, but yet would never be 0 or never be 1. So it could infinitely approach 0 or infinitely approach 1, but it would never achieve that level. The values will fall somewhere between close to 0 and 1, and that's the value that's going to be returned back. It's important for us to look at that, because when we start looking at the values that get returned back, we might see things that are 0.99999, and those are as close to 1 as we can get. And so we're thinking that that's going to actually fall into whatever the ones class is. That could be the yes on the loans, or the yes, the patient is going to respond. Or we might get something that is 0.00001, and we think, well, no, that's probably as far back as it's going to get. The patient's not likely to respond. We should not be loaning this person money. But what's going to happen more often is we're going to get things that are going to be like 0.7, 0.8, or 0.2. And we have to set a threshold to determine, okay, what logically makes sense? What from our experience have we been able to discover that, a 0.7 is likely, or higher, is likely to pay back the loan. A 0.2 or lower is probably somebody who's not going to respond to a medical treatment. So we have to look at these, because it'll split it in half. We can see there's half that are above, half are below. Which ones are the ones that are likely to be the ones we want to focus in on? It may not make sense to say, okay, if somebody's above 0.5 in their particular value, their predicted value, we are going to classify them with the ones. That may not make sense if, in fact, what you're dealing with is loan applications of the people at 0.5. It's really hard for us to predict, and we need to be very confident that they're going to pay that loan back. So we may raise our threshold to 0.75 or 0.8 because we've got so much history and so much confidence based on our model that they are, in fact, going to pay that back. So anyway, bottom line, the linear regression model is going to return for every single record a value that ranges between 0 and 1, and it's going to be that value that you can use to make the prediction as to what the behavior is likely to be, dependent on the situation. So we will build a logistic regression model, and the model is going to take in a series of input variables. We have to determine what input variables we want to use. Similar to what we did when we did multiple variable regression, we did a correlation and we tested out different correlations, and we looked visually at the plots to try to determine which of the fields were going to be the best ones to select for our multiple regression model. Well, we'll do something kind of similar here. So we're going to go ahead and we'll take a look at the independent variables, all independent variables. I'll talk about that more in a second. We're going to compare them to a dependent variable. This is going to be in our training data set. Remember, we already have training data, and we're going to compare that to a variable that's a dependent variable that's already known, right? And it's through that process that we will establish the probability or likelihood that any given record is going to fall either to class 0 or class 1. Class 0 could be no loan, class 1 is give them a loan, through the use of odds. So again, by taking a look at the independent variables, we run through the process of calculating a value of 0 to 1 to determine whether or not we should put it in class 1 or class 2. The higher the value, the more likely that it falls into the 1 class. And then the lower the value, the more likely that, not necessarily that it falls into the 0 class, it's probably more likely that it just doesn't fall into the 1 class. It doesn't achieve whatever threshold we've set to put it into the 1 class. I've already talked about the need to set a threshold. Oftentimes it's necessary to set a threshold. Records above 0.5s might become 1s, whatever 1 represents, and records below 0.5, but it's, again, going to be largely up to the user to set that threshold. Let's talk a little bit about the model. Okay, what linear regression did for us is it created values, and we were able to go in, and for each record we were able to sort of use the model. First created the model, and then we were able to create the values, and we could create the predicted values. We could sort of do something similar with logistic regression, but what logistic regression is really focused on is creating the model. It's creating a trained model, a model that's been trained on training data. And so we know that every time we get a new record, we can throw it through this model, and this model is going to return a likelihood that we have the record fitting into class A or class B. class 1 or class 0, whatever. So we're not really focusing too much on the actual numeric value of what's coming out like we did with the linear regression. We're focusing now more on the likelihood that something is going to either be in class 1 or class 2. And that's where linear regression and classification meet. We're still doing some regression work here. We're still looking at old data sets, making a decision based on old data sets, and building a model that we can apply to new data sets. But instead of generating a continuous variable value, we are in fact generating a likelihood of belonging to a particular class. So in this example I've got listed here, we create the model. Under certain conditions, a record gets a value that classifies it as a 1 approved or likely or a viable candidate. On other conditions, the records are not ones. So then we can apply the model to new records. Cut out all the what we can do is we can actually cut out all the new ones or the non-ones, and focus our efforts on only those records that are going to be the biggest hits. And what I'm saying there, not very well, is once we have our model that's based on, say, 5,000 records, trading records, later on when we get another list of 5,000 records, we can apply the model to those 5,000 records and then split them into two classes. There's going to be some number that actually are, positive classes that we would put as what we might call a 1 class. There might be some far larger number, far larger percentage that go into the 0 class. Well, it might be the ones that we're interested in. So what we've done by applying this model, and if we're fairly confident in the model, it's a good thing to apply the model, is we've cut out a lot of work, a lot of time, and a lot of expense, because now we can focus in very heavily on those records that actually rise to the level that deserve our attention. In this week's example, we have 5,000 records from a fictitious universal bank. And what these 5,000 records represent is we sent out 5,000 loan offers. So we picked 5,000 customers at random and sent them an offer to apply for a personal loan. We got a really small hit rate back, a really small percentage of customers that took us up on the offer. So that cost us a lot of money and took us a lot of time, and it was a really limited return. So could we approach this in a different way? And what we could do is, in fact, we could approach it in a different way. We can classify these records as ones that did respond and ones that did not respond. And we can start looking at the variables that might be the independent variables that might be predictors of response. Here are, it's a view command from of the 5,000 records. Of course, I can't show all 5,000, but I can show you all 14 columns. We have things like ID, age, experience, income, zip code, family, that's credit card average, education, mortgage, personal loans, securities accounts, CD accounts, online usage, and credit card. If you look at the personal loan variable there, you see that there's a lot of zeros and not a lot of ones. What we want to try to do is we want to try to focus in on the ones. That's great if we know what the ones are. That our work's done for us. We just pull out all the ones. Problem is in the next 5,000 rows that we're going to get next week, we don't have that value. We don't have personal loan. And so now what we're going to have to do is we're going to have to try to look at 3 of the variables or 2 of the variables or all of the variables and try to predict what personal loan is likely to be based on what those values are. So we will first run a logistic regression against all fields. And here, this is a little different. With linear regression, what we did is we ran a correlation, and we checked, ran a multidimensional correlation so that we could check which fields were correlated to which fields, or which fields were correlated to the dependent variable. Here what we're going to do is we're going to first run a logistic regression against all fields, and it's going to return all fields. And it's going to tell us what the coefficients would be if we used all fields in our model. But before we do that, we're going to pop over and look at the right side, and we're going to see what are the p-values. Remember, p-values are the likelihood that the results you got were purely by chance. So we want the smaller p-value, the smallest p-value actually, the smaller the better. So what we'll do is we'll look at all of the variables, all the ones that we actually run through this model, and we'll see which ones are probably the best options. They're going to be the best options because the coefficient that we got was based on data that had a very low p-value, had a very low chance of just being purely by chance. So we want to go through and get those variables. So the first one is really going to be sort of like a information gathering stage. And then the second one, we'll build a model. I happen to know that we're going to use income and education because those 2 variables in the first run of logistic regressions showed very, very low p-values. So we're just going to include those two. Now, we can include other ones because there's other ones that have low p-values, but it just selected those two. So we're going to assume that they're going to be those are going to both be good predictors, and we'll build a new model. So we'll use the glm command to build a new model, and once we have our new model, we'll actually apply it to our data set. All right, remember, in logistic regression, we are building a model based on training data that we'll apply to all new records. It allows us to predict how the new records are likely to be classified, and we actually do that using a command in R called predict. We'll play around with predict a little bit, because what I want to do is you've got your output variable, you've got your loan variable. I forgot the actual whatever. Find it. The variable name I'm looking for is personal loan. Anyway, we've got personal loan. So what we'll do is we'll build a model where we can predict whether or not personal loan is going to be set either to 0 or 1, and we'll compare that. Once we have that, we'll have a predicted value, and we'll have it against the actual value of personal loan, and we can compare, kind of visually, we'll compare how close those are. And then remember, we also have to get set a threshold to determine, is it really going to split out at like 0.5? Anything above 0.5 is something that we'll probably work with, or is it going to be something that really should be higher? And that's where the visualization comes in, is that we can sort of make a determination where we want to focus our efforts. And then it'll give us a numeric cutoff, and that numeric cutoff range will allow us to eliminate all records that fall below that, because those are ones that are not worth worrying about. Okay. So what we're going to do is we're going to pop over to R now, and we're going to take a look at the LogReg script that I've given you. It's posted in the resources for week 8. And also make sure that your universalbank.csv file is in your right locations in your working directory on your PC or your whatever machine you're using. Just a note, to get around having to make sure that your file's in your working directory, there's a command, there's actually a function that you can use called file.choose. And the file.choose command can be buried into a read.csv function. So you could say your data frame, whatever your data frame name is set equal to read.csv, and then just pop file.choose in there, and you don't have to even specify a file name. What that allows you to do is it'll bring up your Windows search functions or your Apple search functions or whatever, and you'll be able to find your file. Just search for your file just like you normally would. It's pretty convenient, pretty easy. I've had you actually loading file names up, but I don't know if you are, but I'm a terrible typist and find that I forget the quotes or I forget something or I type it wrong. And the file.choose thing is pretty easy to type, and I can just find my file and click on it. It's pretty easy. Okay, now we're going to run through the script that I have provided. So I'm going to go ahead and get out of here, go to R. And what I am going to do is open a script, which I've called LogReg for Logistic Regression. And we'll run through it bit by bit. You'll note I have put a ton of comments in here because I'm trying to explain command by command what these things are doing. So just you can read through those. I apologize for any typos in them, but I'm focused more on trying to get the information into you or to you than anything else. So we're just run through these. These are just commands for you. All right. Bank.df is our data frame. We're going to read CSV, universalbank.csv, and we'll go ahead and read that file in. And then we are going to drop 2 of the columns. Column 1 and column 5 are not necessarily useful, so we're just going to get rid of them. That's the ID and the zip code, so we'll just dump those. Then the next thing we're going to do is we're going to convert education as to a categorical variable for later processing. Okay, now we're going to divide our data up into training data and validation data. We've seen this before, so I don't have to go through that. You've seen how we've done that before in previous scripts. Then we're going to, and that's as simple as all the preparation we need to do. Then we're going to go ahead and get ready to run our regression model. So let me get there. So we use the glm command. We use lm for linear regression, but we're going to use global regression. It's a general linear model. And we use a term called family equals binomial to fit to a logistic regression. That's how we tell it that it's logistic regression, by using that family equals binomial. So here we go. We're going to set logit.reg is the name of our model. And that is where we dump our model when we actually run this glm command. So we're going to go ahead and run that now. And we have just created the model. Okay. Now we're going to set options equals SciPen equals 999 so that we don't have tons of digits in our view. Basically, when we view, and then we'll run a summary command to look at our model. And there is a whole bunch of stuff over here on this side that lets us see what our model is. Now here is, the first thing is our intercept. Just like in linear regression, we get an intercept. That is just basically the starting value. Okay. Then we look at all of these other fields. We have age, experience, income, family, credit card average, and so on. And we see what the p-values are. Now we can see up here, I'm sorry, these are the coefficients, and I pointed at the wrong thing, but these are the coefficients that we would use. We have standard error z-value, and then we get down here to the p-value. Remember, we're going to use p-value to try to figure out which of the fields would be the best ones to use. Now if we look at experience doesn't look like it has a very good p-value, and you can tell by the stars. They put these little stars down here to tell you what your p-values are, what your range of p-values are, and both age and experience come up with really high p-values, so it's really random, and there's not a lot of order to it. So we're gonna not even consider those. We have income. That has a very small p-value. It is less than this value, so it is a pretty solid p-value, which means the relationship between that variable and the loan variable are very tight. We have other ones that are a little less tight, but a lot of them get the 3 stars for the p-values. Education graduate, education advanced professional. We have CD account, online credit user, online bank user, that kind of thing. So what I decided to do is I decided to say, okay, we're going to go with income, and we're going to go with education. Now we still have education in the file. It's just the education has been broken out into different dummy variables, but the education is still there, so we can still use it. So we're going to go ahead and use income and education, and we're going to create a new model. And again, this is just when you run against everything. And remember how we run against everything is we do the glm is the command. We're looking at personal loan, and we're comparing it against the period means everything. So we're comparing it against everything. Our training set is our data set, and then the family is binomial. Remember, that's so that we can run the logistic regression. So what we're going to do now is we're going to narrow this down. We're going to rerun this, and we're going to rebuild our model. It's going to go back into LOGIT-REG again. But we're, instead of looking at everything, we're going to look at income and education. Let's go ahead and do that. Okay, these are comments for you. Here's building our new model. Okay, comparing personal loan against income, and remember we add plus education. We want to add another field when we're doing this comparison. Family equals binomial to run a logistic regression. Okay, let's take a look at the details of the model. All right, we have income, we have education graduate, and education advanced professional. Those are the values. They have very good p-values. We have an intercept, which is negative 11.581067. We have a coefficient for income, a coefficient for education graduate, and a coefficient for education advanced professional. In linear regression, what we would do is we would start with the intercept, and then we would take, for all 5,000 records, we would take the income variable times this coefficient. We take the graduate variable times this coefficient, and the graduate advanced education professional graduate times this one, and we'd sum them all up and we'd come up with a value. That's not what we're doing here. What we're doing here instead is we've created the model. The model says, okay, when I'm going to go ahead and I'm going to try to calculate that value between 0 and 1 to determine how likely a particular record is going to fall into, I'm going to accept the personal loan offer or I'm not going to accept the personal loan offer. I'm going to use all of these coefficients in order to do that, but I'm not going to calculate a value. I'm going to calculate a probability. I'm going to calculate a likelihood that the customer is going to accept that or not. And that is the model that we just created. Okay, so we have our model created, and now we're going to take a look at what we can do with that model. More comments for you. All right, here we're going to create a prediction. Actually, what we're going to do is we're going to take the model. Remember, we called our model logit.reg, and we're going to use the prediction. We want to predict using this model on the training data set. Okay, and this governs the way that we actually do this. And it's going to create a list of predictions, one prediction for every one of the 5,000 records that is based on our model for all of the records. Actually, it's less than 5,000 records. 60% of 5,000 records are 3,000 records because we did split that out. But you get the idea that it's for the 3,000 records that are in the training data frame, we are going to actually create a prediction for each one of those based on our model. Okay, so let's go ahead and do that. Okay, and now I'm going to create a new data frame. And the reason why I'm creating this data frame is because I want to know how good is my model, right? So if I create this data frame, I have two things I want to compare. I will have the actual, I'm lucky enough to have the actual personal loan value from the training data frame, right? So there's the training data frame $ personal loan. That's the actual value. That's going to go in the first column, and it's going to be called actual. The next column, second column, the only two columns in the whole data frame, is going to be predicted. It's going to be what came out of my model. When I did that Logistic Regression model, the prediction there, and created that Logistic Regression prediction value, it's going to come in there. It's going to merge those two and put them side by side. Let's go ahead and do that. Okay. Well, how did they compare? Well, I could look at them number by number, but you know what I'm going to do instead is I'm actually going to look at some histograms. I want to see them side by side, plotted actually top to bottom. I'm going to see some histograms. And that's an easier way for me to get a distribution of the values. The other thing that's useful for this is it allows me to think about thresholds, right? I'm thinking about, you know, there's a bunch of records that are going to fall into the zero bucket or the not considered bucket, or the people who didn't return that loan application. But there's going to be a bunch that did. And, you know, in our training data set, we have zeros and ones. And again, if we have zeros and ones in the personal loan variable, our work is done. In our new data, we're not going to have that. So we're going to have to sort of set a threshold. And this will make more sense as we actually run these plots. I'm going to run these plots in a little bit of a different way. I want to see the plot side by side, so I'm going to actually run some commands. First of all, I'm going to attach to the data set, and then I'm going to set up to run a 2x1 plot. And then I'm going to populate that 2x1 plot. First with my histogram of actual, then with my histogram of predicted. And now I can take a look at my plot and see how does the distribution look. Okay, this is a histogram of the actual. This is 3,000 records. I have 3,000 records in this set. And of the 3,000 records, the vast majority of them said that they were not interested in our loan offer. But we had some that were interested in the loan offer. Okay, and that's the actual. Now if I apply this and look at what we would have gotten if we'd used the predicted, we see pretty much not too terribly different in the number of people who said no. But now the number of people who said yes is distributed amongst these different values. And remember, these run 0 to 1. It's either going to be 0, no way, no how, I'm not going to apply for your loan, or 1, yes, I'm absolutely going to apply for your loan, or it's going to be some value in between. And again, remember, it's not exactly 0 or exactly 1 ever. It's just as it approaches 0 or approaches 1. So this is why the threshold becomes important, because the model will give us the sort of range of possibilities, the range of likelihood. So would we focus then on anything from 0.5 up? That seems to limit the number of customers that we would actually use. Or would we drop our threshold down to, say, 0.2, maybe even 0.1, right? Because what we've done essentially is out of 3,000 records, we've cut 2,000 plus out and gotten rid of them altogether and said these guys are just, the demographics seem to suggest they're not going to apply for the loan offer that we have. And if we do that, we maybe have limited now the number of applications that we would actually send out to like around 500. That's a lot easier, it's a lot cheaper, it's a lot faster. It's a lot less work to have to process through to get those out. Okay, so that's where we can sort of see that visual, and we can set that threshold to try to determine what we actually want to do. All right, the next thing we're going to do is we're going to say, okay, well, we built this model, and the model looks pretty good for the training data. The model is really helpful for the training data, but how good is it when we are looking at the validation data, right? Remember, we always want the validation set because we want to make sure that we didn't just create a model that is overfit for our training model. If it's overfit for the training model, it's going to look really good with the training data, but it's not going to look like anything good at all with any other data sets. So this is why we really want to go through and make sure that we have done our work and checked it against the validation data. So, time to validate the model. We're going to use predict again. But this time, instead of using, and we're going to use the same variable name, the same model name, and instead of using the training data set, we're going to use a validation data set. So we are going to take this predict command, we're going to look at the model. That's our model name, is logat.reg. This time we're going to look at the validation data set. We're going to dump all the results into this variable. Okay. Done. Okay. Now we can build a new data frame, just like we did before. We built it, called it 4plots, or 4plot. This one's called 4plots, plural, and that's going to actually combine the actual value in our validation set and the predicted value that we've just dumped into that variable. So we'll go ahead and do that. And we'll go ahead and build those plots again. I've got to fix this. All right. And we're attached. We're setting up for a 2x1 plot. There's the first one, there's the second one, and how do they look? Well, it's not terribly different. We still have a giant chunk of them that are like, no way, no how, I don't want your loan. We have a smaller set that are interested in the loan, but we do see that the numbers are a little different. There's a little less, as far as the bar of the histogram goes, there's a little less actual numbers for each of these, but that's just because there's fewer records. But I don't think the distribution looks all that much different. And again, we have to decide what our threshold is, whether it's 0.2 or 0.1 or whatever we want. How much effort are we going to put into these ones down here that look like they could possibly be ones that are interested? It just depends on what those numbers turn out to be. The bottom line, though, is that the validation data set seems to return the same thing as the training data set. So it gives us some confidence in our model. And now we can actually use this model with maybe a little more testing. We can use this model against the new data sets. The data sets we're going to get next week and the week after and so on. So we can determine how do we weed out a whole bunch of these customers who are unlikely to apply for this loan anyway and save ourselves a whole lot of money, a whole lot of time, and a whole lot of grief. Okay, let's go back to our script. All right, so what can you say about the usefulness of our models? All right, let's go back to our PowerPoint presentation. Okay, for this week, you've just seen me work through the script LogReg.R. Okay, I want you to go back and I want you to modify the second GLM function, and we're going to throw age in there. Okay, and then I'll have you build the new model. It'll create the new model in using the same variable names that we have. Apply the new model using the predict command, and you can do this on the valid.df dataset. It doesn't matter, but valid.df, that way I know what you're turning in. But I want to see kind of what your histograms look like, and I want to see how they compare visually. And I also want to see what your summary command looks like. So your summary command is going to be the same summary command. If you use the same model name, you'll use the same summary command that I used in the script. But I want to see what those values are, and then I want you to tell me what the addition of age did. What in your idea, or what in your understanding of this process, how did age impact this? And just turn that in. Put that all into a Word doc and turn that in for this week's assignment.